It's the moment you've been waiting for, actually solving example problems. I surely hope you're not starting here. If you're starting here, you're probably going to get very, very lost. So I really need you to take a step back and go back to some of the previous videos and look at the different ways that we go through all the techniques that we need to do to solve these. Do not start here. If you're starting here though, hey, good luck. So we want to find 96 over the x squared plus 10 minus 10x. We want to find that integral. So what I need to do is I need to take a look here. All right, my first step, use long division. Do I need to use long division? No. So step 1 is already complete. The second thing I need to do is factor that denominator. So I need to say x squared minus 10x is x times x minus 10. Simple enough. The third thing is I need to separate linear factors. What does that mean? Well, what that means is I need to take this equation and I need to separate it into each of these. So this is a linear factor because it's degree 1. So that's a over 1, the factors. And then that's also a linear factor because, again, it's degree 1. So b over x minus 10. All right, now I have step 4, which is to separate the quadratic factors. Well, there aren't any quadratic factors because there's no single factor that's degree 2. So this is already done. So we're really at step 5 here. So step 5 is what we're going to do is we're going to multiply both sides by this denominator. We're going to multiply both sides by this. So multiplying both sides by x minus 10. What that's going to do is that's going to eliminate all of the denominator on the left. And then the x's are going to cancel, so I'm going to have a x minus 10. And then the x minus 10 is going to cancel, so I have bx. So what that does, and that's part A. Again, this is of step 5. And part B. And part B is next. What we need to do is we need to pick convenient values. Now, in the case of linear factors, this is actually pretty easy. What you want to do is you take values that are just going to zero out the linear terms. So, for instance, if I plugged in 0 here, if I said, what happens when x is equal to 0? Then nothing changes there. This becomes a negative 10, and this becomes 0. So what I end up with is that 96 equals negative 10a. So if I divide both sides by 2, I get like 48 and negative 5. So I get negative 48 over 5. A is negative 48 over 5. So that's one value, that's A. Now to get the other value, you say, okay, what's going to make this A term disappear? Well, what if x is equal to 10? I say, all right, then that term disappears. Sorry, still have a 96. So now I have 96 equals 10b. So b is positive 48 over 5. Simple enough, right? So once we have those two pieces together, we can rewrite this. We can say, okay, this integral is now negative 48 over 5 times 1 over x plus positive 48 over 5 with 1 over x minus 10 dx. Right? That's all we're doing is plugging in for A, plugging in for B. Well, this is 1 over x is a fairly straightforward integral. That's just natural log of x. So I end up with negative 48 over 5, natural log of x. And 1 over x minus 10, well, that if I use a u sub of x minus 10, now I have 1 over u. So that's also a natural log. So I have plus 48 over 5. Sorry, this is absolute value of x. And that's really all there is to it for that. It's negative 48 over 5, natural log of absolute value of x, plus 48 over 5, natural log of absolute value of x minus 10 plus c. So by splitting that up with linear factors, what you find is this is a much more straightforward process than if you have quadratic factors.